Alright, so today is a new topic. It is a breath of fresh air after classes and structs and pointers. This is a nice and easy topic for once again, okay? We're going to talk about how to read from files and write to files. And C++'s version of files, it thinks of it as like a type that like you're bringing in data and you're sending out data. It's called a stream. We'll talk about that. That's just a metaphor, but we'll get to that. So let's finally not like have our brains explode in a lecture and learn how to write to files, all right? So there is a type for that, of course, just like everything else in C++. It's called OFStream, all right? So this is going to give us the ability to write to a file, okay? And this actually gives us another way to output things, right? So at the moment, before this lecture, we only have one way of showing something to the user, like giving them information back, right? And that is through just cout. All we can do to give information back right now to the users of our programs is to display stuff on the terminal screen. That's all you get. OFStream is the second option. It's a type that's going to hook into a file and allow us to write to that file. And so that's another way to give back output, not during the program's execution. It's just going to write to a file, and then you can go look at the file after it's finished. So that's the goal, all right? So you're going to make an OFStream object, and you give it a file name. It hooks into a file name, and then it's going to write to that file. And then it will appear magically in your current directory after you have finished running the program. It's going to be great. So OFStream, it's a type. It lives in a new library called FStream, and it stands for output file stream. So it's OFStream. It's going to give us a new way to output. Let's see. PowerPoint does not remember your preferences, sadly. So I gotta do this every lecture. It's called OFStream. It stands for output file stream. It is like a competitor to cout, because all we could do right now is like say cout 42 and put it on the screen. We can now give 42 to a file, which is great. Okay. So the type is beautiful. You say OFStream. You just make an object of that type. I'll call it like OFS or something. And then ... you hook it into a file name. We'll get there. And then you can start using it like cout. You can be like OFS, give it 42, and that will write 42 to a file now, which is beautiful. So that's the goal. Okay, so let's go and maybe look at the library for that. That is over here. Input output, FStream. And we would like OFStream, output file stream class. And there's a bunch of different ways to do it. The constructor is a way to take the file name, but you can also say .open, like give it a file name right now. So OFS .open it. Here's the file name, then you give it stuff. Then you close the file, and it's changed the file. It's written to it. It's so cool. So that's going to be the setup. So you're going to include FStream, make an OFStream object. That means you declare it. And then we're going to open the file. Give it a name. You just pass along a string that you want, and that's the file it's going to create and write to, if it doesn't already exist. And then, we're going to write using like a cout style operator. And then we always want to remember to close our files the second we're done using them, so that they can be accessible to other programs. That's the goal. So what we're going to do is we're going to make a program that writes 1 to 10, not to the screen, but to a file. So maybe we'll call it 1 to 10.txt. And by the time our program is finished, it will have written 1, then 2, then 3, all the way to 10 to this file. That's the goal. Okay, so not anything crazy, but that's the start of it. Let's call it 1 to 10.txt. Oh, not txt, sorry, .cpp. It's going to write the file called .txt. Excuse me. So we're going to include FStream. So that gives us access to OFStream, the type. And so we're going to declare it. So OFStream, OFS. And then we want to open the file in this object. We open the file with the file name, just pass along the string, OFS.open. You give a string, that's the file name you want to open. So we'll call it 1 to 10.txt for a text file. And so that'll have it open and ready to write to. Alternatively, you could do this in one line, okay? Alternatively, you could have done something like this. You could have said, instead of all this, you could have said OF stream, oops, undo, OF stream, OFS, and you can also pass along the file name in the constructor, 1210.txt. That's another way to do, that's the equivalent of these two lines, okay? So either way works. You'll see me use both, but we'll use these just to spell it out. So these two lines are equivalent to the above line. All right. So now we got the file open, and now we can just pretend OFS, that's the name of our object, pretend it's cout and start giving it stuff. So for int I equals 1, I is less than or equal to 10, I plus plus. And instead of saying cout I, new line, give it to OFS. Yeah.
So will this make a new .txt file if there is none already that exists?
That's exactly what it'll do.
If there is one that exists, it'll open that one instead of creating more?
That's right. It's not going to like somehow make two files both called 1to10.txt. There can only be one. Yeah. Yeah. So there's that. We've now written to the file, and it will by default be closed for you the second your program ends or the second the scope ends. But it's good practice to always close the file object that you're writing to, because then it can be immediately accessed by somebody else. So it's good practice to close the file, just like we opened it, right? The opposite of open the file, as soon as you're done working on it. So even though the program is about to end, it will be automatically closed, but just imagine this was in a bigger context. This is a good practice. OFS.close to close the file. To say we're done writing to it. No more. So that's the program. That's legitimately it. G++, 1to10.cpp, -0, 1to10. I do not have a file called 1to10.txt in my current folder, but once I run this program, no output, but I got that file. Look at that. Isn't that beautiful? And so looking at it, there it is. And it has exactly what you would expect. It has the numbers 1 through 10, just like we printed it to the screen. It's been printed to the file, essentially. Any questions about that? This is much better than pointers, right? This is easy to wrap our minds around, hopefully. Easier.
So now what happens if we run it again?
That's exactly what I'm going to do on the next slide. Yeah, good question. We're getting there. So, yeah, it's always a good idea to close that file, .close your file, even though it will be closed for you at the end of the scope. It's just really good practice, all right? And by scope, remember, that just means once you hit the nearest closing curly brace, if I can draw a closing curly brace, that's when it goes away, all right? But usually you want to do it before, all right? Let's see here. All right, so now let me rerun this program. There's two options, right? There's two options for if I rerun this program. It could either add to the end, we'll see 1 through 10 twice in the file now, or it will just overwrite it, and it's chosen that option. So every time I run this program, I can run it 50 times. It's just going to overwrite the existing file if it's already there. It'll make it if it's not there, but it'll overwrite it if it's already there. So nothing has changed. It's going to keep on writing to that file. It clears it out at the beginning. So that's the default behavior of OF stream, right? It'll keep replacing the file. Sometimes you don't want to do that. Sometimes you want to keep what's there and just add to the end of whatever was there, right to the end now. And that is called, in computer science, appending to the file. We're appending, you have the word end inside of append, right? We're appending to the end of the file. And that is, that's so we can do this. We can make a program that like keeps what was there, 1, 2, 3, all the way to 10, and it'll open up the file and have it start writing towards the end. So we can like add an 11 down here in a different program if we wanted to. So if we wanted to do this, this is how we do it. We got to open it in a special mode, in append mode, and that's a second option that's you can give to open. So by default, it opens it in like overwrite mode, but we're going to open it in append mode. So we're going to give that option. We'll say ofs.open, give the file name again, file name, and then we're going to open it in ios_base app for append mode. So it's a little wonky, but that's where it lives. And then you can start saying, as usual, give it a value, give OFS something to write, and that will start writing at the end of the file. It will preserve what was there. Okay? That's called appending. So let's go and make a file that does that, appends to that exact same file. So I will, honestly, let me just reuse this file. Append.cpp. So, here we go. And we're going to open it in append mode. We're going to be like 110.cc, comma, iOS_base : app. That's your append mode. And now I can give it 11. Alright, I hope that makes sense. So now if I run this, I get no output, but it preserved the contents of the existing file, and now it has 11 at the end. We weren't writing 1 to 10 in this program. That was this one. Just 11 only. So if I run it, it's going to add 11 to the end of the file, and if I run it multiple times, it's going to add multiple 11s. There's the contents of the file now. So I ran the program 4 times. You see 4 11s at the end. Okay? So that's appending to a file. You open it up in special mode, separate. It's like, don't overwrite. Start writing at the end of the existing file, please. Okay? So that is append mode. Any questions about that?
In order to append, do we have to do it through the .open function, or is there a way to do it through the constructor?
Just like you had the ability to open the file in one line with the constructor call, you could have also said iOS, given the option here, how to open it. So yeah, the constructor would also have done the same thing. Very good. Yeah. Any other questions about that stuff? So you could do it in one fell swoop with just the constructor as well. Because usually when you make an OFStream object, you're ready with a file name. So it doesn't have to be a 2-step process if you don't want it to be. Let's see here. And now I do want to blow your minds a little bit. So let's think about types. You've never thought about cout, right? Cout's type before, have you? Like, it's not an int, it's not a double, it's not a string. I just give it stuff. It takes that output operator. Like, what is it doing? Cout has a type. We never have thought about it. It's some class. It's an object of some class somewhere, and cout's type is called ostream. Cout's type. Maybe that's what I should have said. Cout's type is an ostream, and so is OFStream. Sorry, so is OFStream. OFStream and ostream, they have a common ancestor, which is ostream itself. So let me prove that too. Here's iostream. Boop. That's where cout lives. Click. Here is the type of cout. It is an object of type ostream. Cool. All right. And OFStream, what's called inherits from ostream. Where can I show that to you? I gotta click on the type. Here it is, and then here is the inheritance hierarchy. So OFStream, it is its own type, but it's taken stuff from a simpler type called ostream, which is cout's type. This is a CSCI 41 concept. You do not have to understand the words I am saying. The types relate, though. That's the key. So what does an ostream give you? By being an ostream somehow, what do you get? That's where that output operator lives. That's why it works on cout, and it also works on OFStream. Haha. That's all I wanted to say. So ostream is just another type. It's the type of cout. And OFStream, while it is, yes, a type, it inherits from another type. That's a possibility in C++. You have a chapter in your book on that I'm never going to ask you to read, but feel free to look at it. That's a CSCI 41 thing. It's called inheritance. So you can take a piece of a more basic type for yourself. And so OFStream inherits from ostream. Draw it like that. And so at the end of the day, an OFStream is an ostream. It can function as one. Okay? That's the idea. So because cout and OFStream objects, any of them, they have related types. They are related, like cousins or something. They work similarly. So that means you have this output operator that exists for both of them. Like this is what it means to be an O stream. You have all these things, one of which is this output operator. Some are some other things that exist on Cout that you have never used before, that you could use. So yeah, that's why. That's the long story for why you could say Cout, that operator, that works, and then OFS, give it something with that same operator. It's because it's an O stream. Okay, that's the idea. Does that make enough sense? It's a little weird, but that's the full story. And I had to go there because here's something you can do once you know that. You can write a function that takes an arbitrary thing of type O stream, and then you could have it write to whatever was passed, whatever O stream was passed to. So we can make a function called write 1 to 10. It takes an O stream reference, and inside call it OS. You can give it something with that output operator, and you could have passed along. You could have called this function with a file, or you could have called it with Cout because the types align. That's really cool. So you can make one function that would write to a file if you pass along a file object, or pass along Cout. It will output to this terminal screen. It's amazing. So let me show that to you. That's just because the types are related, because they're both O streams deep down somewhere. That works. ostreams.cpp. Since I'm going to write from 1 to 10, let me steal this file. Boop. So yeah, here. Let's do it this way. Let's make an OFS object as usual, and then here's what I'll say. I should close the file eventually, but here's what I'll do. I'm going to make a function called write 1 to 10, and it will take an O stream. Don't know which one, but it'll take one of them. And so O streams, we now have an output operator, so I can do this to it. Boop. It's called OS. It has an output operator. I can write 1 to 10 in it. That's fine. And so now look what I can do. I can use this function, write 1 to 10. I can call it with OFS, and OFS will become the O stream OS, and it will print from 1 to 10 to the file. But I could just as easily do this. Write 1 to 10, give Cout as the argument to the function. Now that we know its type, that's fine. You can pass Cout to a function. It will be called OS for a split second, and then you're Couting to the screen. So this program is doing the same thing to the file and to the terminal screen, printing 1 to 10. Does that make sense? That's super cool, in my opinion. So let me show that to you. Boop. So when I run this program, not only will it print 1 to 10 to the screen, because we're passing along Cout as one of the arguments to this function call, it will also have printed and overwritten that 1 to 10.txt file, because we're giving it the file too. So there it is, back to being 1 through 10. And that is O streams. Now we know the type of Cout, we can pass it along, and it will work just the same as if we passed along a file too, because the types are related. Any questions about that? It's a cool little concept, I think. Let's see here. I think we have plenty of time today. So, plenty of time to start your lab, maybe. That's all that I have to tell you about writing to files. That's either open it in output mode and overwrites, or open it in append mode and you start adding to the end. You also have the ability to read from files, as you would expect. So if there's a file that exists on your computer, you can open it up with a aptly named object with a cool type, and you can start getting stuff out of it, just as if you were getting stuff from CN. There's going to be a correspondence there. So it's called, as you would expect, IF stream rather than OF stream. It stands for input file stream. Okay, and this is a third way to get input from the user, isn't it? So we've been able to get input from the user, maybe fourth if you count get line is separate to CN. you can use cin to get it, like a number, a string, whatever, from the user, or you can use getLine with cin to get the whole thing, get an entire line of stuff. And that gives you input from the user's keyboard as your program is running. It stops it, asks the user to type something, press enter, right? Your other option for getting input was to use command line arguments, argc and argv, so that's going to get input from the user, space-separated stuff, right before the program starts running. So right before they press enter and start the program, you're passing those things to argc and argv by giving those command line arguments. Here is your third option. You can read from a file, right? And it's going to be very similar to OFStream. And you declare it, you open it. And then it's also very similar to cin. It has that, there's some types related again. Cin's type is an I stream, as you might expect. Change the O to an I. And then that's where you have the input operator living. Okay, so we can go there. Where's IOStream? Where is cin? Cin's type is an I stream. What does an I stream give you? Among other things, it gives you that extraction or get input operator. Cool. And then in FStream, you have your IFStream class, which inherits from iStream, and so that's why it has all that stuff. That's where the arrows go. Okay? So again, you open the file, etc., etc., and then you can start reading from it. With this operator, inherited from iStream. Now you know what that word means, kind of. So yeah, again, you have opening and closing. Again, you could also open in the constructor. It's there. I think that's pretty much all I want to say. I want to give you an example, more or less. I think that's good enough for that file. Let's make, I guess I'm not ready yet. Let's keep on trucking. So here's our first idea, all right? So cin is an iStream, so is an IFStream. How fun. Boop. And ints is a word. Okay. So here's our first example. Let's make a program that reads the first 5 ints inside a file. So IFStreams can like read into a certain type. It doesn't have to be like, let's read a line, let's read a string, etc. You can read an int if it's stored in a file. That's fine. As long as like the file has white space separated numbers. And oh goody, we have a file that looks just like that with some white space separated numbers. So let's read the first 5 numbers of this file, let's say, and we'll like sum them up and print out the sum. Okay, so that will be our first goal. So I'll make a new file called ifstreams.cpp, and I'll include fstream. It still lives in fstream. Both of them live in fstream. And now I will open up the file called 1to10.txt. That's its name, right? I'll open it up for reading with an ifstream. And again, you could be like declare it, .open it, but let's open it in the constructor this time. So we're going to give we are going to give the name of the file right here. We're going to say 1to10.txt. And so that will open up the file for reading and start reading at the start of the file. Right? And then we're going to read the first 5 ints from the file using that extraction operator. So it's just as if like the user was typing them to us. And we're going to keep track of the sum. So int sum equals 0. And so let's do 5 things. 5 times int I equals 0, I is less than 5. I plus plus. So 5 times I'm going to get a single number from not cin, not asking the user for it, next num, from the file, ifs, read into next num. That's the secret. And then add it into the sum, of course. That's legitimately all. Just like you read it as if the user was typing to you. It'll start reading from the file in order. And you can read into ints. So once you're done, you say ifs.close, because we are good C++ programmers. We don't need ifs anymore. It can go and let other programs open the file. And then we wanted to read all this so that we can keep track of the sum. So let's output the sum. Notice that I don't want to put the IFS line down here. I don't need to. There's no need for it because this line does not require the file to be open anymore. So it's always, you close it as soon as you can. Be as efficient as possible, right? Because this is the second you don't need it anymore. Now you just output the sum. Boop. And so apparently the sum from 1 to 5, because those were the first 5 numbers in the file, I'm going to assume that that is 15. Yeah, 9, 10, 15. Cool. So that's how you read the first 5 ints that appear in the file that are white space separated, just as if these were typing them and pressing enter. It's all the same, more or less. All right. Any questions about this? Yeah.
So the IFS, that will automatically go through each, as if it was like a get line or something?
Yeah, it would find it's. Yeah, it's going. Since you're reading it into an int variable, it's playing the game that CN plays. It's like, I'm going to go and find an int now. I'm going to read an int and then stop at like white space. That's how it's separating things.
So why does it not just give you the first integer and then just continue to give the first integer? Why does it go through each?
That's a great question. It's trying to be nice to you. It's essentially, you think about it, like when you open a file, and I think I'm going to explain this in a different slide, but this is a great time to do it anyway. When you open the file in IFStream, it's essentially, you think of it like it's open in like Microsoft Word, and it places that blinking cursor at the start of the file. And then every time you read something, it moves the cursor so that it's ready the next time you read to read after that. It thinks that you would like to go through the file. It's trying to be nice. Yeah. And so then you're ready to read the 2, and once you read that, moves the cursor after the 2. Once you read the 3, moves the cursor after the 3. And so the next time you say IFS read into an int variable, it'll find an int, read it, move its cursor. Yeah. Does that answer your question? That's essentially what it's doing deep down.
What if you wanted to just give you one? Like,
if you wanted to repeat the one, there is a way to move the cursor back to the start of the file again. And that would be, oh gosh, I don't usually do this. I think it would be probably, it's seek, right? Seek, I think. Is there a way to do that again? Alternatively, you can just repeatedly close and open the file, but I think this way, yeah, that's the only thing I can see. Yeah, seek. And you want to seek back to the start of the file. So irs-base ::beg for beginning. You can go back to the start like that with something like that. You seek it back to the start. That means move the cursor.
Is there also like a way to find like just like from the moment you open the file, say you just want 5, but it's like halfway down? You also use seek for that?
No, this is like which character in the file do I want to put the cursor at? It wouldn't work like that. No, you have to read in a loop through the file. So find the 5.
It is even contained in the rest of the file until we've actually gone through.
Yeah, you can make your own function, of course, that like searches through it, but it would not be seek that does it for you. That just moves to some. It's like you think of a file as a long string. Seek is essentially move it to an index. Move the cursor to an index. Yeah. That was weird. So yeah, that's that example. You might want to read more than 5 ints. You might have a file that like you keep appending to in a different program, and you're just not sure how long the file is. How can you read until the end, always? So here's, let's see, how do I do that? So we want to read the whole darn file. Let's figure that out. Let's figure out how to do that. So, yeah, here's the secret. So we like to read the whole file, and so the question becomes, how do we know when we're done? How do we know when the file is over and we've read everything, all right? So here's the secret. Any iStream object, CN included, and I've had you do this before, any iStream object can be converted to a Boolean value if you use it in a place where a Boolean is expected, okay? So that means you could do something like this. You could say if IFS, and that would be a valid thing to ask because IFS can convert itself to a Boolean on command, all right? So what does it mean when it's true and what does it mean when it's false? So if it turns itself into true, that means the file object is still okay to be read from. Something like that. That's how you think of it. And so the ifstream object, or your cin object, it stops being true once you've reached the end of the file and you try to like read past it. So the second you have a read that tries to go past the end of the file, it sets your ifstream to false, essentially, if you try to check if it's true or false. All right? So that is the secret. You can use it. You say if ifs, and as long as it's true, you can still read. Or technically, you should do it in the opposite order. You should read and then see, hey, if ifs, are you still good? If it is, that means that read was successful. That's essentially the idea. All right? You can do the same thing. There's a .eof on ifs that gives back whether or not it's hit the end of the file. So that's also a possibility. Let's go to that. ifstream. That's inherited from, of course, iStream. It's called EOF. I guess it's inherited from something above that as well. So you can say, you can call the .eof method on your ifstream object, and it will give back a bool whether or not it's hit the end of file. That's what EOF stands for. And so you can use that as like an if statement or as part of a while loop. In a certain order, though. The order is very important, so that's why I have a lot of words on this slide. So, yeah, this will return true or false if it's tried to read past the end of the file. And so the key is, all right, putting this together with what we've seen before, you can read as the condition of an if statement or a while loop, which is kind of weird, but it's possible. Because, all right, so this line, if you say this, if you say ifs read into some variable called s maybe, if you do that, it will first try to read and update s if it can read like at the int or the string you're asking it to read into. And then the result of this input operation will become ifs. This becomes ifs after it tries to run this thing and give it to you and like set the variable. So that will turn into ifs, and then ifs, because this is like part of an if statement or something, will become true or false, telling you if that read just worked or not. That's the key. All right. This evaluates to ifs, so like it becomes ifs after it tries to read, and then ifs will tell you if it's true or false. It'll tell you if it succeeded. If it's still true, it worked. If it's false, you should not look at s right now because it did not successfully get a new value into it. So all of that taken together means that you can do this, and I've had you use this before, but this is why. This is why you can say while ifs reads something, just make that the condition. While ifs you can read something into s, in the body you do something with s. So that means your read was successful every time that's true. The second it's false, it'll stop the loop. So you can use that kind of style, that kind of programming to read a bunch of valid values from your ifstream object until the end of the file. Because hitting the end will say that it's false, and it will stop, and the read will not have been successful. So that was a lot of words. Are there any questions before I show you an example of that? All right, so that's the secret. Let us sum every number in this file, all right? And I'll show you EOF could work the same way. But this is the secret. I will make a new file called sumeverything.cpp. Include fstream, of course. And then I will declare an ifstream object, ifs, open the thing, 110.txt. Eventually, I want to remember to close it, so I'll be a good C++ programmer and say ifs.close. And then I'd like to create the sum of everything. So really, honestly, I can steal most of this. Let's steal most of this. And so, boop, open in the file. Instead of summing the first 5 things, I can read in a loop like this. I can say, I'll have to declare next num outside though. While I can read from ifs into next num, while it's true that I can get a new valid int out of this ifstream object, then it worked. All right. So as long as this is true, you'll hit the body. The body only ever executes if the read was successful. So that's great. And then I want to take that next num that I just got and add it into sum. Sum plus equals next num, and this will correctly sum up all of those ints in that file, assuming it's made up of a bunch of white space separated ints. Okay? Question?
Real quick, I just had this idea pop in my head. When you're declaring IFS up at the top, will it accept any string, even like a string variable?
Yes, absolutely. So I could have been like, I could have gotten the file name from the user, for example. Name equals 1 to 10.txt, and then file name. That would work. Yeah, absolutely. Let's see, but this is going to sum everything, so let's watch that work. It'll stop once it hits the end of the file. This will become false, and the read will fail. And so apparently the sum is 55, and that is true. I think I've memorized at this point that the sum of the numbers from 1 to 10 is the number 55. It's 11 times 10 over 2, so 11 times 5. Yeah, perfect. That's read everything. And if there was more, it would read those and add them into the sum, of course. So yeah, I think, where was I? I was here. So that's that. That's why that one works. Does that make sense? Any questions about how that's working? We've seen the syntax before, but now we're using it with files. And then alternatively, if you wanted to, you could use ifs.eof to like check, hey, did that read work? Did that read work? You'd have to do it in a weird order. You have to do it after the read, but that would also do it for you. So technically, the second you get out of this, ifs.eof is true, like it's hit the end of the file. True for yes, I have reached the end of the file. So cout ifs.eof, its result is that, which should be 1 for true. Yes. And it would be 0 before. So yeah, that's what's going on. That's how that's working. Any concerns, questions, comments? Because honestly, I have one last example for you, and yeah, I want you to try. Your turn. So I'd like you, I'll give you plenty of time for this, like take 5 minutes, and then I'll show you my way. Try writing a program that repeatedly gets a line from the user and appends that line to a file. Maybe like you need a stopping condition, so like maybe stop when the user types like the line that contains only Q or something. But your goal is to like ask the user as many times as they want to type a line for you. Like type hi, you'll use getLine as usual. And then the second they type a line, add it to a file with some name. I don't know, call it like out.txt or something. The second they type hi, enter, you get that line and you write it to the file. The second they type mom, enter, you get that line, write it to the file. Does that make sense? And then if you say like blah, hit enter, it writes it to the file. So you can pick a file name. And then once they say Q, it stops. It doesn't write line Q to the file, it just stops, right? And I want you to append so that if you were to rerun this program and it starts asking for new things, you say like hello, it'll add to the existing file, all right? And then Q to quit. Does that make sense? So you can open up an append mode, that is iOS base : app. And so let me give you my append code just really quick, and then I'll let you go off for a little bit. Oops. Here's my append code. So this will be similar to what you'll be doing. Come on, Windows, you can do it. There you go. So there is that. Do you understand the assignment? You're getting a line from the user's keyboard, so you're using getLine with CN, but then you're taking that line and shoving it into a file with a name of your choosing. And you want to open it up in append mode so that if you rerun this program, it adds to the end of that file. Okay? Does that make enough sense? So take some time, try that, and then I'll show you my way in like 5 minutes. So you can get it working. So you can think of it as like, I don't know, like a guest book at an Airbnb or something. Like you're always adding to the end of it. You're not deleting stuff. You're adding your comments. Or you can think of it as like a comment to a video or something. Like it's a comment system. Start adding stuff. Adding line by line until you're done. Need to respond to that. Put it into close your file. Alright, that was my timer. Let me show you how I'm thinking about it. Did any questions come up while we were trying this though? Did it make enough sense? If you just had enough time, maybe you could have done it. Let's take a look here. So, I guess I can steal a lot of this append file, so I have that. And we'll call it getLine and append.cdp. And I don't want to overwrite my 1 to 10.txt, so let's call this out for output.txt. So there I am, closing the file once I'm done with it. And so what am I going to do? I would like to, let's open it with the constructor. Why not? Let's be like, boop. There, one cool thing. And then I'm going to repeatedly, while true, forever, potentially, get a line from the user, and then add it to the file. Alright, so string line, I need a string variable, so I need the string library, and then give me that line user, so cout, enter line, we'll get line with cin into that line variable. Cool. Now you can make your own get line now. Maybe you know the type of cin, and you know that line is passed by reference because it's updating it. Let's see. If line was q, so get line removes the new line, so we'll have to add it back when we append to the file. If line is q, then we're done. So break out of this loop. Otherwise, if we're still here, this is a line that is not q that we would like to add to the file. So add this line to the file that we open in append mode. So OFS line and put in that new line too, and then close the file. So that's pretty much it. Does that make enough sense? Any questions about that? Yeah.
Can you just put the if statement into where the
While line is not equal to q, something like that.
Yeah.
Well, I guess the problem is initially we don't have a line. It's kind of out of order. Does that make sense? Yeah. That's why I'm doing it this way. The solution would be to use what's called a do-while loop. Have you read about that in your book? That I don't even know if your book talks about it, honestly. But that's the opposite. It's where the condition comes after the body wants. And so that solves the ordering problem in a cool way. Yeah. Yeah, it's you can always you don't need it. It gives you no extra power, but sometimes like now that could have been the right time for it. So that's an option too. So yeah, I need that line first before I check it. That's why I did it like this. Alright. So let's compile and run. Get line and append. What was my example? Hi mom blah q. Hi mom blah, and you could type spaces right now because you're getting the whole line, then q, and it stops. And so it wrote that whole darn thing to out.txt. If it does not exist initially, even though it's in append mode, it will create the file. So that's fine. So here we are in we got out.txt. It has everything I typed. Hi mom blah. And because we opened it in append mode, if I add more things like hello q, then it adds it to the end. Yay! And it preserves everything. It's like a comment system or a guest list. I don't know. Check in something. But that's the idea. That's my silly example. Any questions about that? Now that you've seen it working. Don't forget to close your file. Alright, if we are happy, I think that is that's the last thing I wanted to show you today, so hopefully you're convinced like this is not a hard set of slides. This is much better than classes and pointers. It's a breath of fresh air, and that's why I put it in between hard topics. Alright, so let's see here. I can stop this. And we can go here, and let's give your lab. So this will be the 20th. So what is that? Next Friday? Oh no, your current lab is due this Friday, Friday the 13th. So this is lab 6. So that means this is a 2-week lab. There's a reason it's 2 weeks. So definitely start early. This is rational numbers again. Since we got so good at them in this lab, this time we're adding classes. All right, so we're making rational number objects, methods on them. It's going to be great. So let's look at the code. 46. It's trying. There it goes. So here are your 3 files. Similar looking to before, but this time we're packaging up a rational number, not as just like 2 parameters to a function. That's kind of silly. We can make a rational class, and every rational number object can have a numerator and a denominator, just all in one. That's as it should be, right? That's the power of classes and object-oriented programming. All right, so we're going to take what you did. Most of what you did, you're just going to copy and paste it in a new way, okay? Change it a little bit. You'll take your function-based implementation. So this is one of the few labs in this class where you have to do the previous lab to get a good score on this one, okay? So that's important. And then we're also going to we're going to do the add method on rational numbers in addition to the multiply. And that involves finding a common denominator, which I assume you have all stressed over in a math class once upon a time. So here we go. So you are going to implement rational.cpp, all right, which is the class implementation of the rationals class that's defined in rational.h. All right, you're going to implement every member function, and so everybody who wants to use your class will include the header file and get your implementation in the CPP file because you're compiling with it. Okay, so just go to rationals.cpp, start implementing the methods. They're pretty much the same as your last lab. It's just you have stuff as your member variables now. Okay, that's the new thing, but like you have a constructor. Right? That's also a new thing for classes. So you got it like a constructor. You have to set your numer and denom member variables based on what the user gave you for n and d. Okay, so you have a parameterized constructor, and you're just setting your member variables. All right, that's one thing. And then you have some other options, right? You have toPrettyString, which you can just copy and paste mostly. You have now we're making operators instead of just rational times or rational multiply, whatever we called it before. So let's talk about that. Oops, I don't want to change that. Let's do it this way. So you have your simplify function. It becomes a method. It's a simplify method that you can call on yourself just by calling it like a function. It takes no parameters because it's implicitly modifying you. Right? It's a member function. You modify your own numer and denom. Does that make sense? That's what simplify does. So that's a private method because we don't want the user calling it either. So here is simplify again, but it's your job to set your numer and your denom based on using GCD and getting rid of negativity and all that fun stuff. But it's being called on you, right? You're calling it on yourself. So it's just a method. It's messing with your own numer and denom. Just reset them, okay? It is a method of the rational class. I hope that makes sense, okay? And then the rest are very similar. It's going to be toPrettyString is a const method that returns the string, of course. Again, no parameters necessary. It's creating a string out of yourself, right? Somebody's calling it on you, the rational object, and you have inside of you a numer and a denom, okay? So this should have been simplified for you. That's the one change. You can assume that your rational number has already been simplified, so you don't have to call it into toPrettyString, and then you just convert it to a pretty version of yourself. The simplification actually is going to happen in the constructor now. So set numer and denom and also call simplify on yourself. All right. To call a method on your own object, just call it like a function. Just say simplify. Boop, just like that. There's no like. There is a concept of like me.simplify, but I haven't taught you that. It's called this. It involves pointers. Let's not go there. So you call it on yourself, and that's your constructor. toPrettyString returns a string version of yourself. And then instead of like rational times, you have the multiplication operator, right? You have yourself multiplied with somebody else, some other rational number, right? So your job is to return a brand new, a third rational number. That is the result of multiplying things. So you have your own numer, and you have like other dot numer. Does that make sense? Other dot denom. That's how you're getting it. You're getting the other fraction as another object, okay, called other. And so because simplification will happen in the constructor, you don't have to call simplify yourself here anymore. You're just going to figure out what the new numerator and the new denominator should be for this new multiplied number, and just call the constructor and return the rational number. The constructor will do the simplification, right? Because every constructor call is simplifying. You've made sure to do that. Okay? And so that's pretty much it. The last thing, the new thing, besides the classes part, is you're also going to be implementing the plus operation on fractions. So same as times, you're getting, you have yourself, and you're adding that to some other fraction, some other rational number with its own numerator and denominator. And your job is to build a third fraction that is the result of the sum. And to sum fractions, right, because you're not sure what they are, it could be anything, you have to find a common denominator. All right, so here's the formula if you don't remember. This is BD becomes the common denominator, and then like it's AD plus BC over BD. So this is your numerator. This is your denom of the summed fraction. Okay, so you have to implement that. Does that make enough sense? So that's how that works. And then I've made you plenty of tests to show you how all this is supposed to work. That's your test.cpp file. And I also want you to write some tests, so that's why it's a 2-week lab. So here is some tests already made for you. Here's how you do it. Like here I am making a rational number with these numerators and this denominator. And so calling .2 pretty string on that rational number, here I am calling the constructor to set it and simplify it. Calling 2 pretty string should make this just like before. Okay, do you see how it's changing to be object-oriented and cool? And then here's your times function, your times operator, right? It's operator star. So you make 2 rational numbers, you give them like this. You just say star now. That's beautiful. And this is translated into R1 dot operator star on R2. And so apparently this is the result. Okay? Calling 2 pretty string on the result. Does that make sense? How these are being used? Very similar. And then here I am summing 2 rational numbers, making R1 and R2, operator plus, and apparently the answer should be this. All right? Simplified. There's probably a lot of simplification going on because this is over 45 and this is over 42. So that somehow becomes over 18, which is great, I guess. So that's nice. But yeah, those are the tests. Get those passing. And then, once you have them passing, like you should see this, right? The output of my tests. And then once those pass, you write your own tests. I would like you to write 2 tests, please, of your own. You can test any combination of anything, like, I don't know, test adding 2 fractions and then multiplying it by a third fraction, and then figure out what that should be. Make a test for that. Something like that, okay? So your job is to write your own test, come up with your own scenario, 2 more scenarios that kind of follow my style, but you call assert true twice more. So you should see 5 passes total in the end, all right? 3 from my tests, 2 from yours. And that's it. So come up with some tests with some scenarios that you think of. Compare what you're getting to what you're expecting. Call assert true. And that is the end. All right? So you're implementing the rational class, getting my tests to pass, and then writing your own tests. Okay? Any questions about your tasks? So all this, you're implementing in the CPP file, all those methods, and then you're also writing 2 tests, similar to my tests. So that means you're turning in 2 files, the implementation file and the test file, since you're adding stuff there too. Okay, so that will be your lab, 2-week lab. Please start early and ask lots of questions. But I think that's everything that I wanted to say. Does that make enough sense? Any questions before I let you start? All right, so that, I believe, is all that I have for us today. The rest of the time is yours to get started.